security challenge. Today we're having a lot of sensitive data on our smartphone. We have fingerprint, we have facial recognition for facial unlocking the phone. Tomorrow, these sensitive data might also need to be stored on other devices, right? You might have your fingerprint stored in your smart door lock, or you might have your facial information stored in some smart cameras, etc., or your smart TV, etc. So how can we make sure that all these devices are secure enough to be able to store your sensitive data in a secure way? Okay, that's the challenge. Second challenge is another challenge is that in the future, because all of these devices works together, means they're connected with each other. So if one device is compromised, it might pose risks to other devices which are connected to them. So we have to make sure not only the device that store your information is secure, but also the devices connected to these devices are also secure. Okay, so these are some the new security challenges that today's modern OS are facing, but they're not facing these challenges in the past. Okay. Third is what I talked about, the siloed ecosystem, right? So today we have different OS for different devices. You know, we have millions of apps for smartphone, which is great. But these apps are many times not available on other devices. So when you're looking for, when you like some apps on the smartphone, you cannot find them on the smartwatches. Okay, that's the problem. Why is like that? Because from the developer perspective, if I'm a developer, if I develop an app for your smartphone, it takes me a whole lot of extra effort to adapt this app to other devices, because other devices using different OS. Okay, for big companies out there, it's not a problem, but for small and medium developers, they don't have enough resources to do this kind of adaptation across different devices. That's why you end up having a very unbalanced ecosystem across devices. So these are the challenges that today's OS is facing that we are not facing them before. Okay, so you might, and we already talked about that it's very difficult to just simply modify the existing OS to face its challenges. Okay, so we identified, because of the challenges, that we identified some of the key characters of the OS, that what the OS should look like in the future to be able to overcome, face the looking at, take these challenges. Okay, first we think that we want to deliver a seamless experience to the users. Okay, so we're looking for OS where in that OS all the multiple devices can share capabilities and serve as peripherals for each other. Okay, what does this mean? Because as I said, in this context, with the smart home, mobile offices, there's multiple devices, but each device have their own advantage from hardware perspective, right? For example, your screen on the laptop is bigger than a screen on your smartphone, right? The sound effect coming out of your smart speaker is better than the speaker on your smartphone, okay? And there might be a better microphone out there, a better camera out there. But the smartphone has its own advantage. There's a lot of apps on the smartphone that your laptop doesn't have. Most of your photos is on smartphone, not on your laptop. Okay. So, but before, in the past, all these apps can only use the hardware capability of that device where the app is on. We think in the future, in a seamless world, all these hardwares can work together with this app to deliver the best user experience. Meaning that when your phone receives a video phone call, and that video phone call app can discover that there is a better screen beside your phone, there's a better speaker beside your phone, there's a better microphone beside your phone, and that FaceTime app can utilize all these hardware peripherals across all these devices to deliver the best video call experience to the users. This is an example. Okay, so this is what I mean by serve as peripherals for each other, okay, shared capabilities. We think that's the true multi-device experience. In order to do that, there's a prerequisite for that, is that all these devices have to speak the same language, right? And that means all these devices have to run the same OS, okay? Which means we need to have one OS that is able to be deployed across devices, okay? So that's what the second means. We need to decouple the OS and hardware. Okay, today this hardware is this OS, that hardware is that OS. That has to change in the future. Okay, in the future it has to be one OS for all the devices. And from the developer perspective, developers should not develop different versions of the apps for different devices. Okay, they should have one version, one code base, one project of their app, and their app can run on different devices. Okay, so making the developer life easier. And of course, performance and security as well. Okay, if the future app cannot run on a new OS with a better performance and better security, other things doesn't mean anything. Right? Okay, so these are the characters that key characters that we identified for future OS that is aiming the cross-device experience, the IoT in the future. Not necessarily our OS, but I think any future-oriented OS should go after these characters. But we think that today's OS is too much of a legacy to work on, and it's possible for us to simply modify the existing OS to adapt to these characters, and that's why we are thinking about creating a new OS from the ground up for this kind of future, okay? And we call it Harmony OS. So Harmony OS is a microkernel-based distributed OS for all scenarios. Okay, I already explained what all scenario means. I will spend some time next a few minutes to talk about what microkernel-based means, okay? And what the distributed OS means. Okay? So the Harmony OS has 4 distinctive advantages compared with the modern OS today we have. First is distributed architecture. Okay. So I think recently, after the Huawei Development Conference, we heard a lot about distributed architecture, but what it actually means. Right? First of all, we talk about in the future, we need to have one OS on top of all different devices, right? So the key to achieve that is to have a modularized, decoupled Harmony OS. This may sound a little bit technical. Okay, let's try to say it another way. It means that you have to break down your OS into very small granularity, so that in the future, when a new device comes along, you could just piece together these components like you piece together Lego bricks, right? So that it can adapt to a new device. Quickly. And so that's one of the benefits of microkernel. Okay? Microkernel means small piece. Okay? When it's a small piece, that is easier to be available across devices. Okay? And so for all different kinds of devices, we have different services. Okay? The services available on this device does not need to be deployed on other device, so we can just take them away. Okay? So that's the first thing. Okay, your OS has to be modularized, has to be decoupled, so that it can run across devices, whether it's a device with a big memory or small memory, even down to kilobytes of devices. We can run Harmony OS in the future on them, okay, so that they could work together. So after we have a unified OS across devices, that means all the devices speak the same language. So what? Okay, what is the benefit of that? The benefit is that we could virtualize all these hardware capabilities across all these devices to become a virtualized resources, so that they could be shared by the apps across devices. Okay, as I give you example in the video phone call. Okay, so that you might have a video phone call app here. Okay, And from this video phone call app, this video phone call needs to use a display, a camera, a speaker, but these devices from the app perspective is virtual devices. Okay? Physically, they could reside in different devices around you. Okay? I could use a display on the smart TV as the display of my video phone call. I could use the speaker on my smart speaker as the speaker of my video phone call. Okay? I could use, I don't know, maybe the microphone on my smart watches or microphone on the smart speaker as the microphone for this video phone call. Okay? So that all these physical devices around you can work seamlessly together, making the experience like the app is working on a virtual super device. Okay? And how it is possible? It is possible because of the distributed architecture that we implemented in Harmony OS. And so there's 4 key technology components that makes this distributed architecture possible. The first one is distributed virtual bus. Okay, sorry, but before that, just a little bit explanation of, I think we all have some sense of what distributed means. Okay, distributed computing means we put a computing tasks across different computers to do that, right? Okay, so distributed experience and architecture in this context means some apps or some tasks or some interactions are breaking down to different pieces and handled by different devices. Okay, and that's what distributed means. So distributed virtual bus is the components that handles the communication between devices. It means one device can discover there's other devices around it, and it can automatically connect with other devices. Okay? So there will be no pairing procedure for the users to do, as they do today. Okay? Also, there is different physical layer that support connection, like Wi-Fi, like Bluetooth. So all these physical connections is handled by the virtual bus. Okay? And virtual bus also handle the quality of services. For example, if there's some problem with the communication, and then it's the virtual bus to handle these problems, not the apps on top of it. Okay? Device virtualization is what I just talked about. So we can virtualize all these different peripherals on different devices into virtual peripherals, virtual devices, and can be shared by the apps. So apps doesn't have to deal with different devices on different peripherals on different devices. They only work with the virtual peripherals, and so it's easier for the apps to handle. Okay? Distributed data management. This is also a very difficult part because if you're doing something across different devices, you come across the issue where some data is written by multiple devices at once, right? So how can we maintain the data integrity? How can we ensure that the data is properly synchronized across devices, right? So all these difficult things is done by the distributed data management. Okay, distributed task scheduling means that I could break down the video phone call into several different tasks. Okay, some task is acquiring the video footage, some task is broadcasting the audio, etc. So we schedule these different tasks across different physical devices at the same time. Right? So these are the 4 key technical components of distributed architecture, and we have built that into Harmony OS. There's a lot of technologies that goes into here. There's a lot of technological advances that goes into this distributed architecture. One example is in the distributed virtual bus, we have actually optimized the modern TCP/IP protocol. Okay, so on the left side is the traditional communication protocol that we used for decades, right? And it's been there since some of us were born. And it works well when we have a long distance communication, like cable or wireless, etc. But when in the future that the communication may happen between two devices where they're sitting together on the desk. So in that case, in that scenario, a lot of technologies we build into the traditional legacy communication protocol becomes redundant. And so that's why we have simplified the traditional communication protocol into on the right architecture. So there's 4-layer protocol. We have simplified into 1 layer so that we simplify the data stream in here, and so we can carry more data that needs to be transferred and is faster and more efficient.